Bismillah al-Rahman al-Rahim. I am Muhammad Shoaib Siddiqui, and you're watching my channel Shoaib Views. My today topic on PLC. This is AI-generated video, and its Urdu version will be coming soon. PLC initially developed to replace complex relay-based controls in automotive manufacturing. PLCs have evolved to become indispensable in various industrial sectors due to their versatility, reliability, and robustness. Origins and evolution. PLCs were first introduced by Dick Morley, the father of the PLC, to automate and streamline processes in the automotive industry, which was prone to the challenges of maintaining relay-based control systems. The original PLCs were designed to withstand harsh industrial environments and provide more flexible operation than their predecessors. Over the decades, the core philosophy of replacing hardwired relay systems with a programmable alternative has remained integral to PLC development. As computer technology has progressed, PLCs have incorporated advances such as microprocessors, integrated circuits, and advanced communication protocols, significantly enhancing their capabilities. Structure and programming. A typical PLC system comprises a central processing unit, CPU, input-output, I/O, modules, and a programming device, all housed within a rugged chassis. The CPU processes observations from input devices, executes control programs, and sends instructions to output devices. I/O modules interface directly with sensors and actuators, translating real-world conditions into comprehensible data for the CPU. PLC programming languages have also matured over time. Initially dominated by ladder logic, PLC programming now includes options such as function block diagram, FBD, instruction list, IL, structured text, ST, and sequential function charts, SFC. These languages comply with the International Electrotechnical Commission's IEC standards, ensuring global compatibility and ease of integration. Applications across industries. PLCs have found applications across a plethora of industries, ranging from manufacturing and food processing to water treatment and energy production. They are integral to processes requiring precision, such as assembly lines, conveyor systems, and batch processing operations. The ability to tailor PLC programs to specific tasks allows for customization and optimization, increasing efficiency and reducing downtime. With the advent of Industry 4.0 and the Internet of Things, IoT, PLCs are expected to become even more sophisticated, integrating with digital ecosystems to offer unparalleled control and data acquisition capabilities. It is evident that the future of industrial automation will continue to hinge upon the flexibility and innovation PLCs provide. Thanks for watching my YouTube channel Shoaib Views. If you still not subscribed my channel, please subscribe it and follow my channel. Also like and share my videos. Press bell icon.